Ma'am, you can start now.
Shall I start, ma'am?
Yes, yes, ma'am.
Yes, ma'am.
A very good evening to one and all gathered here. I'm Sandana Priya from the Department of Electronics and Communication Engineering, here to host today's workshop on a simulated world organized by St. Joseph's Robo Club, St. Joseph's Institute of Technology. It's my great pleasure to extend a cheerful welcome to you all here. On this beautiful evening, I would like to take this opportunity to extend my first and foremost gratitude to our Honorable Chairman, Sir, Dr. B. Babu Manoharan, our Managing Director, Mrs. S. Jessie Priya Ma'am, our Director, Mr. V. Sasti Shekhar Sir, and our beloved Principal, Dr. P. Ravi Chandran Sir, for giving this opportunity. I would also like to take this opportunity to thank our Head of the Department, Dr. Sinyana Kausalya Ma'am, Staff and Student Affairs, Dr. G. Rohini Ma'am, Lab Affairs, for their endless support. I would also like to welcome the Head of the Department and the Lab HODs of the CSE, IT, EEE, Civil and Mechanical Departments and Department of Science and Humanities. I would like to welcome the students gathered here for this session. It gives me an immense joy to welcome you all to make this event a grand success. It's my pleasure to welcome Ms. S. Shweta, the wonderful speaker of today's session. Now, I would like to share a few words about the speaker. S. Shweta, a student of second year EC department, was one of the director of School Rotary Club and presently an active member of the Robo Club, ERC Club and IT Society also. She was one of the subject topper on her 12th grade and have done projects like ATM system, a Pi game, a few more using Python. She have also developed a web design using HTML and CSS. Now, before we start the session, I would like to tell a few instructions to be followed by the participants. Kindly post your queries and questions in the chat box and they will be discussed with the speaker at the end of the session. The feedback link will be posted at the end of this program. Now, I invite our speaker of the day, Ms. Shweta, to kindly start the session.
So thank you for the introduction, Priya, and my special evening wishes to everybody present over here. This is Shweta from EC department who is here to explain the concept, working, construction, connection, and everything about this social distance indicator. And in this COVID time, it is very important for us to maintain our distance between each other, for which the social distance indicator will be of a great use. So what is this social distance indicator? What it actually does? It does nothing but it will calculate the distance between you and the target person using ultrasonic distance sensor. And after calculating the distance, it will check for the condition that whether you are in your safe zone or in your danger zone. If you are in your danger zone, the circuit will alert you through the buzzer sound. So that is a small gist about this social distance indicator. Don't worry about anything. I will explain each and everything one by one. Now, moving on to today's agenda. First, I would like to give a short brief about every components we will be using in our project. And later, I will explain the basic concept behind this social distance indicator. And I will do the connections part in the Tinkercad online simulation tool. And I have my code in my notepad. I will explain each and every line of my code. And finally, I will copy the code and paste it in my Tinkercad tool. And at last, simulation will be shown to you. Now, moving to the components. Here in our project, we will be using only 4 important components. Yes, you heard that right. So the main first important component we will be using here is my Arduino Uno. And the second is my ultrasonic distance sensor. Third, the Neopixel Ring. And finally, I have my buzzer. Now, the first one, Arduino Uno. It is an open source microcontroller board based on microchip Atmega 3280 microcontroller. Yes, this is the technical definition, but to put it up in simple words, I can say that the Arduino reads the data from the environment. And after reading the data, it will work upon the data by the code which we feed to it. After completing its work, it sends the commands back to the environment, and that is how Arduino works. Now, in general, we have 3 sets of pins in our Arduino, that is power pins. This set of pins are power pins, and this is analog pins. And here from 0 to 13, all of these are my digital pins. In my project, I will be using only this power pin and my digital pin, but not my analog pin, right? So moving on to the next component, which is my ultrasonic distance sensor. It is an electronic device that measures the distance of the object by emitting ultrasonic sound waves and converts the reflected sound waves into electrical signals. So we have many types of ultrasonic sensors available, but here we will be using HCSR04 sensor. Now let me explain the working of this ultrasonic sensor. So the ring which you see here is the transmitter, is known as transmitter, and here this is known as receiver. So the sound waves will be transmitted from this transmitter, which will hit on the object, which will strike on the object and will get reflected back. Those reflected signal will be received by my receiver, and that is how the distance between me and the object will be calculated. So I repeat again, the sound waves will get transmitted from my transmitter, will strike on the object and will get reflected. Those reflected signals will be received by this receiver, and that is how the distance will be calculated. And here the important thing to note is that my sound wave is traveling twice the length, twice the distance from transmitter to the object and back from the object to the receiver. So I want everybody to remember this point because we will be using it in the formula. So I repeat once again, my sound wave is traveling twice the distance. Now seeing about the pin, we have 4 pins in my distance sensor. The first is my power pin or my VCC pin. The second is known as my trigger pin, which is also known as my transmitting pin. The third is my echo pin, which is also known as receiving pin. And finally, I have my ground pin. No need to worry about this. I will explain the use of every pin while doing my connections part. Now, moving to the next important component, that is my Neopixel ring. So it is a circular rigid printer circuit boards festooned with Neopixel LEDs. Generally, I can say that it is a circular circuit boards where a certain number of LEDs are chained or connected together. So we have many types of Neopixel rings available. Here, we will be using Neopixel ring 12, which contains 12 LEDs connected together. And the pins which are available in my Neopixel ring are 4. First, the power pin, the ground pin, the input pin, and the output pin. In my project, I will be using this power pin, ground pin, and my input pin alone. I won't be using this output pin, and I'll explain the reason when I'm doing the connections. The last important component is my buzzer. We all know that it is the simple electronic device that can generate basic beep sounds. So that is all about the components. Now moving to the concept of this social distance indicator. Let us assume that this be you and this is the target person. My ultrasonic sensor will calculate the distance between me and the target person, right? And after calculating, if it finds that you are inside your safe zone, only 4 of your LEDs in your Neopixel ring will turn on in green color and you won't have any buzzer sound because you are inside your safe zone. And next, when the target person gets little close to you, the distance between you and the target person is reduced. Thereby, my Neopixel ring will turn on the next 4 LEDs in yellow color, which says that the level of risk is bit increased, and then also I won't have my buzzer sound. At last, when the target person gets very close to you, which violates the social distance norms, all 12 LEDs in my Neopixel ring will turn on, and the last set of 4 new LEDs in my Neopixel ring will turn on in red color, and then only you will have your buzzer sound, which alerts you saying you are absolutely in your danger zone. So that is the basic concept behind the social distance indicator. So my buzzer sound will be on only if all 12 LEDs in my Neopixel ring are turned on or glowing. So moving to the connections. Here we have only 3 steps of simple connections. The first is I need to I need to connect all the ground pins of my components together in the same line. And next, the VCC or power pins of all of my components will be connected in the same line. Finally, the left out pins of all the components will be connected to the digital pins of my Arduino. So let me show you the connections through Tinkercad tool. So here I have my blank page. Finally, I will start getting my components Arduino Uno 3, and I'm placing it over here. Now, the next important component is my ultrasonic sensor. As I already said, we have many types of ultrasonic sensors available. I'm using HCSR04 sensor. And the next important component is my Neopixel Ring 12, which has 12 LEDs. I'm placing it over here. And to make my connections clear and easier, I will be using a breadboard. Mini will be enough for me, so I am placing it over here. And the last important component, my buzzer, I'm placing it here. So I hope everybody can see all my 4 components placed in my blank page. Now it's time for me to start my connections. So as I already said, the first step of connection is to ground all the pins together. So I'm taking the ground pin from my Arduino and connecting it over here. And we represent ground pin generally in black color, so I'm going for black. Now I'm connecting the negative of my piezo buzzer to the ground as well. Now here, the ground of my Neopixel ring should be connected to the ground of my Arduino as well. Connecting it over here. And at last, the ground of my ultrasonic sensor should be connected to the ground of my Arduino, and I'm connecting it over here. So now you see all the ground pins of all 4 components are connected in the same line. Now it's time for me to move on to step 2, where I connect the power pins all together. So I'm taking 5-volt power pin from my Arduino and connecting it over here. And generally we represent power pin in red color, so I'm going for red. Now here we have our power pin in my Neopixel ring, which has to be connected to the power of my Arduino, so I'm connecting it over here. And finally, I have my VCC pin or power pin of my ultrasonic sensor, which should also be connected to the power pin of my Arduino. So we have completed step 2 also. Now what should I do? I should connect all the leftover pins of my components to the digital pins of my Arduino. So what are all the leftover pins we have? We have the positive of my buzzer. So I'm taking it and connecting it to the second of my digital pin, maybe in orange color. Now the input of my Neopixel ring is connected to the third pin of my digital pin in green. Now, as I already said, we will be using only 3 pins out of 4 in my Neopixel ring. Why? Because here the power and ground are connected to the powers and ground of my Arduino respectively. And here my Neopixel ring gets input from the Arduino. That is, it is getting the command from the Arduino to turn on each and every LED. If I connect this output to the Arduino pin or to the digital pin of my Arduino, my Neopixel ring is not giving any sort of output to my Arduino. It is only getting input from the Arduino to turn on the lights. And that is why I am using this input pin to connect it to the digital pin of my Arduino. So if you want, we can ground this output pin, but it is not necessary in this case. So I am leaving it as it is. Now the next 2 left out pins are my trigger and echo pin of my ultrasonic sensor. So I'm connecting my trigger pin with the 5th of my digital pin in the Arduino in blue, and the echo pin is connected to the 6th of my digital pin in the Arduino and in purple. So note here, you can connect the leftover pins anywhere from 0 to 13 in your digital of the Arduino. I am choosing 2, 3, 5 and 6. You can place it over anywhere in the digital pin, but you have to be careful when it comes to code. You have to be careful in giving the correct number. So that is all about the connections. I'll give a quick sum up of the connection. Here we have connected all the grounds together, all the power pins together, and the left out pins, that is the positive of my buzzer pin, the trigger and echo pin of my ultrasonic sensor, and the input of my Neopixel ring is connected to the digital pins of my Arduino. Now it's time for us to go to the coding part. As I already said, I have my code in the notepad. I will explain each and every line of the code, every line in my code, right? Now the first line, #include Adafruit Neopixel.h. Here, Adafruit Neopixel.h is the Neopixel ring library, which is initialized by this line #include Adafruit Neopixel.h. Right? Next, moving on to the next line, int LED pin is equal to 3, where I'm telling the program that the LED pin, this LED pin of my Neopixel ring is connected to the third of my digital pin. So that is what this line of code says. Int LED pin is equal to 3. Now, int LED number is equal to 12, which says that the number of LEDs present in my Neopixel ring is 12. So as a whole, I have 12 LEDs which are chained together. So I am letting my program to know that the number of LEDs is 12. And in the next line, I am initializing a class, an Adafruit Neopixel class, which comprises 3 main parameters. What are all the 3 main parameters? The first is the number of LEDs, which is 12. The second is the LED pin, which is 3, where I have connected to the Arduino, which is 3. Now I have the type of my Neopixel. So what is the type of my Neopixel? My Neopixel is of the color combination red, green, and blue, and my Neopixel works at 800 kilohertz bit stream. As a whole, this denotes the type of my Neopixel, and it is one of the important parameter in my Adafruit Neopixel class. Now, after initializing the class, the value this class returns will be stored in this strip variable, and that is for which we are using the whole line. So the value which is returned by this class will be stored in this strip variable, and that is what we have given as Adafruit Neopixel strip. So generally, I can say that hereafter, whatever changes or whatever updations we are doing in our Neopixel should be informed to this strip variable. Right? Now moving on to the next line. Int buzzer pin is equal to 2. Int echo pin is equal to 6, and int trigger pin is equal to 5. Here I am telling my program that I have connected my buzzer pin, my echo pin, and my trigger pin to the 2nd, 6th, and 5th digital pin in my Arduino respectively. Right? Now moving on to the next line. Int minimum distance is equal to 100, and int maximum distance is equal to 300. So for me to have a safe zone and a danger zone, I have to have a minimum distance as my danger zone and a maximum distance as my safe zone, right? And that is why I am initializing 2 new variables called minimum distance is equal to 100 centimeter, which is my danger zone, and the maximum distance as 300 centimeter, which is my safe zone, right? And moving on to the next line. We know that we will be having 2 important functions in our code. The one is void setup function, and the next is void loop function. First, let us see what this void setup function is. So here, void setup function is used for one-time execution. So each and every instruction inside this void setup function will be executed only once, and that too as soon as the program starts running. And that is the use of this void setup function. So I can say that all the basic general instruction which the program or which the circuit has to know will be given inside this void setup function, right? And inside this void setup function, I have my pin mode. What is this pin mode? It is one of the digital input-output function of my Arduino, which is used to configure this particular pin in the particular mode of working. So here, pin mode function is used to configure this pin either to work as an output or an input, right? So here I'm configuring my buzzer pin to work as output, my trigger pin to work as output as well, and my echo pin to work as input. Why I am doing so? Why my buzzer pin and trigger pin as output and my echo pin as input? I'll explain it. See, now as I already said, this is my trigger pin. It is also known as transmitting pin, from where the sound waves will be transmitted. So I can say that this trigger pin gives some output to the environment, right, in the form of sound waves, and that is why I am configuring this trigger pin as output. Now this echo pin will get the reflected sound waves. It receives the reflected sound waves, and that is why it is also known as recipient. So simply I can say that it gets some input from the environment, and that is why we are configuring this echo pin as input. Now when it comes to the buzzer pin also gives some output in the form of sound to the environment, but it doesn't take any input from the environment. it is only giving the buzzing sound as the output to the environment, and that is why I am configuring this buzzer pin as output. So I hope everybody is clear in this point why we are configuring this buzzer pin and trigger pin as output and my echo pin as input. Now moving on to the next, serial.begin function. What this function does. So serial.begin function is used to connect my serial monitor to the Arduino. What is serial monitor? So here you see in my code, I have a serial monitor over here, right? So all of the values which I need to be printed will be printed inside this serial monitor only if I connect this serial monitor with my Arduino, and for which I am using this line of code serial.begin 9600 function. So the serial.begin function connects my serial monitor to the Arduino. And what this 9600 mean? It means nothing but my serial monitor will work at the rate of 9600 bits per second, which is called baud rate. I'm repeating again, this 9600 means nothing but my serial monitor works at the rate of 9600 bits per second, which is known as baud rate. Now, I am having my strip.begin function. What is the use of this strip.begin function? It is used to configure my Neopixel. It is used to configure my Neopixel. So why do I need to configure my Neopixel? Because I have to get my LEDs to glow in different colors, to turn off the LEDs when in accordance with the changes happening in my environment, I need to configure my Neopixel. So to configure my Neopixel, I am using this strip.begin function. So simply I'm telling my Neopixel to get ready to work in this line of code. So from here, my Neopixel is ready to work. But until now, I didn't give any command to my Neopixel to start its work. So now what I have to do is that I need to activate each and every LEDs one by one in my Neopixel ring. So how many LEDs I'm having in my Neopixel ring? I have 12 LEDs. So now I need to activate each and every LEDs in my Neopixel ring, for which I am using this for loop. For int I is equal to 0, I less than LED number, my I value will get incremented. So this for loop will keep on repeating until my I value is equal to 12. So inside this, I am using this strip.setPixelColor to set the color of my pixel. And here the I value is nothing but the number of LED. Like if my I is equal to 0, currently my program is working on the second LED of my Neopixel ring, right? Now, the strip.color function is the actual color which I am assigning to that particular LED. Okay, so I use the strip.color function to assign a particular color to that particular given LED. So 0, 0. So first here I am assigning 0, 0, 0 color. So it doesn't mean it is black in color, but the dimmest. So here I am only activating my Neopixel. I mean the LEDs in my Neopixel. So for which 0, 0, I am giving 0, 0, 0 as the color combination, which is not black. I'm repeating again, it is not black, but the dimmest. So here after repeating 12 times, all my LEDs are activated. Finally, I'm using this strip.show function to show all the updations which I have made in my Neopixel ring. So as I already said, right, every changes I'm doing in my Neopixel ring has to be informed to this strip variable so that all of those changes can be seen as the output. And here I am using this strip.show function to show all the necessary changes I have done in my Neopixel ring. Now moving on to the next important function, void loop. So what this void loop is used for, what it is used. So every instruction to run in a loop, we will give all those instructions inside this void loop function. So void loop function will run in a loop. So what is the necessity of this void loop function? Why don't we have all of these codes inside void setup function itself instead of this void loop? Let me clarify that. Practically speaking, all the you will be keep on moving, right? The position or your position will keep on changing, and the target person will keep on moving also as well. And so that is how the distance between you and the target person will keep on changing. So in accordance with the distance, your number of LEDs turning on will also change. And in accordance with the number of LEDs changing, Your buzzer sound will be on and off. So all these things are changing in accordance with the environment. If I give code for all these inside my void setup function, it will be executed only once and my program stops there. So later, my system or my circuit won't respond to the changes which is occurring in the environment. And that is why I need void loop. So in all these instructions inside this void loop will sense the environment and will respond according to the environment as many as times required, right? So inside this void loop function, I am the first and foremost thing I'm doing is to calculate the distance between me and the target person. So I'm calling a function to calculate the distance, like calc distance, and I'm assigning it to the variable distance and telling it of data type int. Now basically we know that once a function is called, it will directly move on to the function definition, which is here in calc distance. Now to calculate the distance, I will be using the simple distance formula, the general distance formula, which is speed into time. Now I need to calculate the time of my pulse. So for which I am introducing two new variables, distance and duration. I'm telling it of data type long. And again, next, digital write, what this digital write function is. So it is also one of the digital input output function of my Arduino, which is used to write the particular digital value to this particular given pin. So what is the digital value available? It should be either 0 or 1. Either I have my digital value as low or high. So this digital write function is used to write that particular value to the given particular pin. So here I am writing the value of my trigger pin as low. And the next line, I'm using delay microseconds function. What is this delay microsecond function? So what is the delay function in general? Delay function is a blocking function which is used to pause the program for that certain amount of time. So why do we need a pause? Why do we need to pause the program? To get that particular task to completed, we need to give some time to our program, right? And that is why I'm pausing my program. So here, delay when my program encounters this line, it will pause every code and it will wait for this particular task to get completed, right? So here I'm pausing my function for 2 microseconds. And again, I'm writing the value of my digital pin as high using this digital write function. And then I am pausing my program for 10 whole microseconds using this delay microsecond function. Again, I'm writing the value of my trigger pin as low using digital write. So if you notice here something, I hope everybody can notice something, that here I am producing a pulse in my trigger pin. First, I'm setting the value of low and moving it to high, and then low again. Thereby, I am producing a pulse in my trigger pin. Now, I need to calculate the length of this pulse, which is received by my echo pin. So as to get the duration, so as to get the time, I have to calculate the length of the pulse received by my echo pin, for which I am using this pulse in function. So what this pulse in function does? It will generally wait for my echo pin to go from low to high value. Once my echo pin goes to high, the timer starts. My pulse in function starts its timer. And it will again wait for my echo pin to go from high to low. Once my echo pin goes to low, the timer stops there. Thereby, I have calculated the length of my pulse using this pulse in function. So here I have my length of the pulse, which will be stored in this duration variable in the form of microseconds. So I have calculated the length of my pulse using this pulse in function, and I have stored the value in this duration variable in the form of microseconds. Thereby, I got the time. So for distance, in distance formula, we have distance is equal to speed into time. Here I have my time, which is equal to duration. Now, I need to explain the formula, the distance formula. So I'm going back to my slides. Yes. So here we will be using the general distance formula. Distance is equal to speed into time. And we already have my time as duration. We have calculated the duration, which is time. Now we know that the speed of sound waves is equal to 343 meter per second. So generally I can have two methods for calculating the distance. The first method is that I need to convert this 343 meter per second to centimeter per microsecond. So I'm doing here as 343 meter per second is equal to 0.0343 centimeter per microseconds. And thereby I calculate, by substituting this value in this distance formula, I can calculate the distance. So distance is equal to 0.0343 into duration, and the whole equation is divided by 2 because I already said that the sound wave is traveling twice the distance. So I'm dividing the whole equation by 2 and I get my distance. So this is one of the method, and the next method is that I am converting this 343 meter per second is equal to 29.115 microseconds per centimeter. Not only the value, but also I'm changing the units from meter per second to microseconds per centimeter, and that is why instead of multiplying speed into time, I am dividing the speed. I'm dividing the time by speed 29. And again, the whole equation is divided by 2 to calculate the distance because the sound wave is traveling twice the length. So here, I am going for method 2 because why not? Everybody find method 1 as easy and understandable. So some will have a question like, will this method actually work? So as to show them that this method also works, I am using this method 2 in my code. So moving back to my code, I am having distance is equal to duration divided by 29, and the whole equation is divided by 2 again. Now I got my distance between me and the target person. Now it is time for me to check for the condition. So if distance is greater than or equal to maximum distance. So if my distance, what is the maximum distance I have mentioned there? It is 300 centimeter. So if the calculated distance is greater than 300 centimeter, I am assigning that distance, calculated distance is equal to max distance itself, because I don't care whether I am in 325.163 centimeter from the target object. Anyhow, I am inside my safe zone. So I'm equating this value, I'm assigning this value as 300 centimeter itself, right? Now again, if distance is less than or equal to minimum distance, I am assigning the value of distance is equal to min distance. So I don't care whether I am standing in 60.25 centimeters from the target. I am anyhow inside the danger zone. So it is highly danger for me right now. So I am assigning this 60.25 centimeter is equal to 100 centimeter itself. So finally, after doing all of these changes, I'm returning the value of my distance back to the function call. So I'm using return distance, where that distance will be printed on my serial monitor using this serial.println function. As I already showed you the serial monitor, right? There, I want my distance to be printed, and for which I am using this serial.println function. So it generally prints the value of my distance in the serial monitor. Now, since I calculated the distance, I need to know how many LEDs in my Neopixel ring to glow in accordance with the distance, for which I am mapping 4 important parameters, which are the calculated distance, the minimum distance, the maximum distance, and the number of LEDs. So by mapping all these 4 parameters, I can find out the number of LEDs which has to glow. And for mapping, I am using this map function. So map distance, minimum distance, maximum distance, LED number will generally map, and that value will be stored in this LEDs to glow variable, which gives me the number of LEDs which has to glow in my Neopixel ring. Now, what this one is doing here? What is the use of this one? I am telling that the first LED, I'm telling my circuit that the first LED have to glow regardless of my distance. So wherever the target person be or wherever I am standing, I don't care. I don't want my circuit to care about that. The first LED of my Neopixel ring has to turn on always, because to find out that my LED is working all perfect, I am giving the first LED of my Neopixel ring to be turned on always. And next, I'm printing the number of LEDs which has to glow. So using serial.println function, I am printing the number of LEDs to glow in the serial monitor. Now I have got my distance and I also have the number of LEDs to glow. Now it is time for me to check for the condition for my buzzer pin. So I already said that I need the buzzer alert from my circuit only if all 12 LEDs starts glowing, and that is why I'm giving the condition if LEDs to glow is equal to 12. That is, if all 12 LEDs in my Neopixel ring is glowing, I'm writing the digital value of high to my buzzer pin using this digital write. So here I will get my alert from the circuit. Else, even if only 11 LEDs are glowing in my Neopixel ring, I don't need a buzzer sound from my circuit, so I am writing the digital value low to my buzzer pin, which will turn off the sound. Right? Now let us have a quick sum up of what are all the things which we did until now. I found out the duration of my pulse using pulse in function, and using distance is equal to speed into time formula. I have calculated the distance between me and the target object, and after calculating the distance, I have the number of LEDs which has to glow in my Neopixel ring, for which I have mapped the 4 important parameters, and also I gave the command to my buzzer pin to give me an alert if all 12 LEDs are glowing. Now, until now, you see that I didn't give any specific code for my Neopixel ring to glow in different colors. Like I already mentioned that the first 4 LEDs have to glow in green color, which denotes the safe zone. And the next 4 LEDs have to glow in yellow color, which says that the level of risk is little bit increased. And the last 4 LEDs have to glow in red color, which says that you are absolutely in your danger zone. So for which I need to give code, right? And that is why I am using this for loop. For int I is equal to 0, I less than LEDs to glow, my I value will get incremented. And inside this for loop, I have an if condition because I need only 4 of my 12 LEDs to have the same color. And that is why I'm having an if condition. If I is less than 4, I am setting the set pixel color. I'm using the strip.set pixel color function to set the pixel color, and here the strip color is 50, 0, 0, which is my green color combination. And next, else if I greater than or equal to 0 and I less than 8, I'm setting my pixel color as strip.color 50, 50, 0, which is my yellow color. And finally, for the last set of 4 LEDs, else if I greater than or equal to 8 and I less than 12, I am setting the pixel color as strip.color 0, 50, 50, which is my red. So finally, I have completed giving colors to my LEDs also, and know that the I here is the particular LED where my program is working. So for example, if I is equal to 6, currently my program is working on the 6th LED of my Neopixel ring. And now hopefully I have given code for everything, but what happens if you move far? Like for example, let us have that you got alert from your circuit saying that you are in your danger zone. You will probably move, you will definitely move little far, right, to stay in a safe zone. What happens if you move? If you move, you need your buzzer pin to turn off, the number of LEDs in your Neopixel ring to turn off gradually one by one, right? So until now, I didn't give any code for my LEDs to turn off. And only if my LEDs are turning off one by one, I will get my buzzer sound off. So for which I need a code, and I'm using a for loop. So for int I is equal to 0, I is equal to LEDs to glow, I less than LED number, I values get incremented. And inside I'm using strip.set pixel color, and again I am dimming my LEDs one by one. So if the person moves far after getting the alert sound, if the person moves far, the buzzer sound should go off. To make it to make my buzzer sound to go off, I need to turn off my LEDs or to dim my LEDs one by one, right? For which I am using this for loop, and I am again using the strip.color 0, 0, 0 to dim my LEDs. Finally, I am using this strip.show function to show all of these changes which we are doing in my Neopixel, and I'm using a delay of 50 milliseconds for all of this particular task to get completed. So that is all about the whole huge program, whole huge code. So I hope I have explained each and every line clearly. And now it is time for me to copy paste the code. It is the same code without any comments. I'm having this code without any comments. I have to copy this code and paste it in my Tinkercad. Here I'm not using blocks but only text. Continue. I don't need my serial monitor now. And I'm pasting my code over here. So let me check. I have all. First, I'm initializing my library, telling that my LED is connected to the third of my digital pin, and the number of LEDs in my Neopixel ring is 12, and initializing a class and assigning it to the stripe variable, telling that my buzzer pin, my echo pin, and my trigger pin is connected to the second, sixth, fifth. That is the second, sixth, and fifth of my digital pin. The digital pins of my Arduino. And using a void setup, I am configuring the buzzer pin as output, trigger pin as output, and echo pin as input, and connecting the serial monitor with my Arduino using serial.begin function. And stripe.begin function is used to configure my Neopixel, and to activate the LEDs, each and every LEDs in my Neopixel, I'm using this for loop. For int I is equal to 0, I less than the number of LEDs, I value will get incremented. And here using this strip.setPixelColor function, I am setting this strip.color 000, which is not black but the dimmest. And finally, I'm using the strip.show function, which will show all of the changes or all of the updations which we do in our Neopixel ring. And getting into the void loop, first I'm calling a function and assigning it to this distance variable. Once the function is called, it will move on to the function definition, which is int calc distance. Inside that, I have two other variables, distance and duration, which is of data type long. And now I need to create a pulse in my trigger pin, and I need to receive that pulse in my echo pin so as to calculate the duration of or the time of my pulse. So I'm writing the value of load to my trigger pin using this digital write function, and pausing my function, pausing my program for 2 microseconds for that particular task to get completed. And again, writing high value to my trigger pin and pausing my function for 10 microseconds, and again writing low value to my trigger pin, thereby producing a pulse. Now that pulse which is received by my echo pin will be measured. The length of that pulse will be measured using this pulse in function, and that value will be stored in my duration variable using duration variable in the form of microseconds. Now, after calculating the duration, you can go for any method for calculating the distance. And here I'm using second method, where distance is equal to duration divided by 29, which is the speed of sound wave. And the whole equation is divided by 2 because my sound wave is traveling twice the length. And now it is time for me to check for the condition that if distance is greater than maximum distance, I am equating this distance as same as max distance itself. If distance is less than or equal to minimum distance, I am telling that distance is equal to min distance as well. And I am returning the value of distance, which will be printed in my serial monitor using this serial.println distance function. Now, after calculating the distance, it is time for me to go to have the number of LEDs which has to glow in this Neopixel ring. So here I'm using this map function to map all these 4 important parameters, that is distance, minimum distance, maximum distance, and LED. And if we map all these parameters together, we will get the number of LEDs which has to glow in my Neopixel ring. And I am printing that value using serial.println function. Now, after having the number of LEDs to glow, I need to go for my buzzer pin. So, yes. So, if the number of LEDs to glow is 12, I am setting high value to my buzzer pin, or I am writing high value to my buzzer pin using digital write function. Else, I am writing the low value to my digital write, low value to my buzzer pin using this digital write function. Now, it's time for me to assign colors to my LEDs. So the first 4 LEDs will be glowing in the combination of 50, 0, 0, which is green, and the next 4 will be glowing in 50, 50, 0, which is yellow, and the last 4 will be glowing in 0, 50, 0, which is red. And finally, I'm using this for loop to turn off my LEDs one by one if all 12 LEDs are glowing. And finally, I'm using this strip.show function to show all the necessary updations happening. And finally, I'm delaying or pausing my function or pausing my code with 50 milliseconds to all of these tasks to get completed. And that is all about my code. Now it's time for me to go for simulation. Before that, I will present this screen only. So wait for me. And tap. So I hope everybody can see this screen. And now I'm starting the simulation. And now as you see, now wait. So regardless, as I already said, regardless of my distance, wherever I go, the first LED will be turned on. So as you can see here, right, the first LED is turned on. And this is the range where my distance sensor can sense the distance between me and the target object. So this is the range of the distance. Now notice the change which is happening in my Neopixel as I am reducing the distance. As I reduce the distance one by one, my LEDs will start glowing. After 4, it will be on yellow color, and after 8, it will be on red color. And once all 12 LEDs starts glowing, I'm having my buzzer sound, right? So after 12 LEDs are glowing, I will have my buzzer sound. And if the distance between me and the target is reduced, is increased, my LEDs will turn off one by one until it goes to 1. And regardless of my distance, the first LED will be turned on always as an indication which says my Neopixel ring is working all fine. So that is, I'm stopping the simulation, and that is all about this social distance indicator. Now, I'm back to the slide once again. If you ask me, is this the only project available using ultrasonic sensor? It is absolutely a no, because we have n number of projects. We can do n number of projects using this ultrasonic distance sensor. Here, I have mentioned only few of it, like speed measurement and ultrasonic glasses for blind, water level alerting system, Arduino blind stick, hand sanitizer dispenser using Arduino. All of these projects use the same concept which we are using here. So I have listed out only few of it. You have n number of projects using the ultrasonic distance sensor. And not only ultrasonic sensor, but also you have many other types of sensors also. And here I have listed out only few, like gas, alcohol, or smoke sensor, using which you can have your own, you can construct your own smoke level detector. And using temperature sensor, you can build your own digital thermometer. And likewise, I have gave the accelerometer tilt sensor, which is used to measure it is used to sense the vibrations happening in the structure. And the heartbeat sensor, by which you can have your own heartbeat or pulse BPM rate monitor. And by using barometric pressure sensor, which is used to measure the atmospheric pressure, you can build your own altitude, pressure, and temperature using Arduino. So this is only few of the sensors which I have mentioned here. You have lots of other sensors and lots of projects which can be built using other sensors too. So that is all about today's session, and my heartfelt thanks for everybody who attended this 3 days workshop. I hope and believe that this session was a bit informative for all those beginners to start with their own projects. Once again, thank you so much.
Thank you, Shweta, for sharing your knowledge. Now I call upon Subhanan to take over the session.
So, good evening all. This is Subhanan here to take over the session from now. Thank you, Shweta, for your beautiful presentation and explanation about the topic. Let's move on to the question and answer session. Shweta, here are some questions for you. Will those sound waves emitted from the ultrasonic sensor be audible to human ears?
No, it won't be audible because the frequency of the sound waves emitted from the ultrasonic sensor will be greater than 20,000 hertz. whereas human ears are audible. The audible range of humans are only from 20 hertz to 20,000 hertz. So definitely we won't be, those ultrasonic sound waves won't be audible to us.
Okay. The second question is here for you. What is the non-contact detection range of an ultrasonic sensor?
So here my ultrasonic sensor can measure distance starting from 2 centimeter up to 400 centimeter. So that is the range of my ultrasonic sensor, which is from 2 centimeter up to 400 centimeter.
And the next one, what is the difference between delay function and delay microsecond function?
Okay, so we use delay microsecond function to pause the program for that certain microsecond time. And delay function is used if we need to pause the program for milliseconds. So if it exceeds over few thousands of microseconds, we will go for delay function alone. And if it is only below 1000 microseconds, we will go for delay microseconds function. So the only difference between both is that here in delay microsecond function, we will be using microsecond, and in delay function, we will be using milliseconds.
Okay, thank you. Instead of Arduino, can we use some other board?
Yes, obviously you can use Arduino Nano or Arduino Micro 2. Here I'm using Arduino Uno because it is easy for the beginners to understand. So that is why I'm using here Arduino Uno. You can go for Arduino Mini or Arduino Nano 2 if you wish.
Okay, the final question is here for you. If we remove port serial dot begin function from the program, will it throw any sort of error?
No, actually my program won't throw any error, but instead I won't get any values printed in my serial monitor. So it won't throw any error. If I remove serial begin function from my code, it won't throw any error, but it won't show any values which are printed in my serial monitor.
Thank you, Shweta, for your clear answers.
Thank you so much.
Finally, on behalf of St. Joseph's Robo Club, St. Joseph Institute of Technology, once again, I would like to thank Ms. Shweta for this workshop. My sincere gratitude to the Almighty for always showering us with this immense blessing. My heartfelt thanks to our beloved chairman, Dr. B. Babu Manogaran sir, Managing Director, Mrs. S. Desipriya ma'am, and our Director, Mrs. Sashi Segar sir, for their guidance in the conduction of this workshop. Also, I would like to express my gratitude to our principal, Dr. P. Ravichandran sir, for his support in conducting this workshop, and our head of department, Dr. C. Gnana Kausalya ma'am, staff and student affairs, and Dr. G. Rogini ma'am, lab affairs, for their words of encouragement and guidance. I would also like to express my gratitude to the head of department and lab HODs of the CSE, IT, EEE, Civil, Mechanical Department, and the Department of Science and Humanities for gracing today's occasion. I would also like to take this time to sincerely thank our department staff and the organizing team for arranging this workshop successfully. Last but not the least, my sincere thanks to all the participants for your active participation and support. We truly hope that you took away something of value through this. Kindly fill the feedback form